is what gives us our amplitude, which in other words is how high and low our graphs go from the x-axis. Your b value affects the period, or basically the distance that it takes to complete one full cycle for your sine or cosine. Now today, we're adding on C and D. They were very creative with our four variables that we added, A, B, C, and D. So your A and your B are both multiplication, okay? And those affect the length either going up and down or the length going left and right. If it's on the outside of the function, it's going to be affecting it vertically. If it's on the inside of the function, it's affecting it horizontally. So today, C and D are being added and subtracted. And so those are going to be moving it up and down and left and right. So we have what's called a phase shift, which is just a horizontal shift. Okay. But we treat it a little bit differently than like when I have a parabola. When I move that parabola, it looks very much like it's moved. The reason we call it a phase shift is because our sine and cosine graphs repeat themselves. Okay, it can be hard to tell when it's moved, so I have to like look at the phase, or like kind of how frequently it kind of goes up and down to see if it's been shifted or not. And so that is, so again, because it's horizontal, means it has to be on the inside. So that is C units left or right. Now, notice that we do have a subtraction sign in there, so that subtraction sign means that it is the opposite direction. Now, your vertical shift is just a vertical shift, so it's either up or down. And again, if it's on the outside of our function, is what goes vertically. So it's D units up or down. So those are your 4 different transformations that we can have with our graphs. Now, 2 different things to realize. 1, graphing a trig function, there's a lot of different pieces, so there's like it can take kind of a long time. And then 2, you also have the ability to use Desmos. So there will not be a lot of just like graph this thing on a test or CFA. What I'm gonna do instead is, if you did the slides from last week, it's gonna be similar to that. It'll be find the amplitude of this function, find the phase shift of this function, or I could give you a graph and ask you to go the opposite direction and say, what is the amplitude of this graph? Okay, so I might ask you to graph like one graph, but the rest of them are going to be asking you to find these different pieces, because really these are what's more important than the like graph itself. So speaking of a graph, we are going to graph it, but we're going to work kind of over here on the side, finding those different pieces of the stuff that I talked about. So we're going to go in ABC order, okay? So our A, remember, is our amplitude. So what is our amplitude for this graph? 1/2. Okay. Then next, remember that our B is the period. Do we have a B value here? So is there a number being multiplied by the x? No. So it's just 1. So our period is just 2 pi. Okay. Then next, our C is our phase shift. Do I have a phase shift this time? have a number that's being added or subtracted on the inside. Yes, what is it?
Pi over 3.
Pi over 3. And we're subtracting, but remember we said we moved the opposite direction, so that'll be pi over 3 to the right. Now, do I have anything that's being added or subtracted on the outside? No, so that means that there's no vertical shift. Are we all okay with how we found all of those pieces of information? Yeah?
Can you do the period again?
Sure. So your period, again, remember, is just this b value, okay? If I don't have a c, then it's just like if it was 2x, then 2 would be our b value. Or if I do have a c value, then it's whatever number is right here. Well, notice I don't have a number right there, so it's technically just a 1. Well, 2 pi divided by 1 is still just 2 pi. The 2 pi divided by b is just the formula, so you just have to remember the formula. Other questions? Alright, so if we look at our handout that I gave you, you want to look at your sine graph. Okay, where does sine normally start for the first period? 0, 0, 0, yeah. So we usually start at a 0. Remember, these are what we called our critical points. So we have a 0, and then we go up to a maximum. Then you have your other 0. You go down to a minimum. And then you have to end at the same thing that you started with, which will also be a 0. So those were called our critical points. Okay. We also talked about how we can label our units whatever we want them to be. Okay? So that's why we labeled our graphs in radians, and your handout is labeled in radians, because we're graphing in radians. So we said that we shifted pi over 3 to the right. Yes? So like, and we're starting at a 0, so we are now at pi over 3 comma 0. But if I'm going by pi's over 3, what might it be helpful to label all my units as? So like on your handout, we go by pi's over 2s, because that's where we have zeros and maxes and mins. Here, if I've shifted by pi over 3, what might it be helpful to label this as, my first unit? Pi over 3, yeah. So we're just going to go by pi's over 3 now instead. So this would be pi over 3, 2 pi over 3. What is 3 pi over 3?
3. Wait, no, just pi.
Just pi, yeah. Then I would have 4 pi over 3, 5 pi over 3. What would 6 pi over 3 be?
2 pi.
2 pi. Okay. So we're just going to go by pi's over 3 instead. Now, what did we say the period was?
2 pi.
2 pi. So does that mean that my ending point is going to be at 2 pi? Normally it's at 2 pi, right? But what did we do?
We shifted it to the right.
By pi over 3, right? So where is it going to end now? So 2 pi over...
Another.
It is. 2 pi we said was the same as 6 pi over 3, right? And then if I shift pi over 3, we're now at 7 pi over 3. So we would end at 7 pi over 3. Now, the nice thing about your sine and cosine graph is like they are very like symmetrical, okay? Meaning that, so I have a 0 to start and a 0 to end. Exactly halfway in between is where our other 0 is. So we are 6 units across here. So my other 0 will be 3 units in between. And then exactly halfway in between my first 2 zeros is our maximum. And exactly halfway in between my second 2 zeros is our minimum. Which is why that like pattern is helpful, because even if we kind of switch the locations, we can always like find the pattern for our points. Now, where is our maximum going to be this time?
0.5.
It is. So these are 3 so I'm gonna go 1.5 units, and it's gonna be up at 0.5, and then where's our minimum gonna be? Negative 0.5. So those would be our key points. And as long as we kind of remember the general shape, that's really the only points we need, because then we can just connect them with a nice pretty curve, and that would be our graph. What questions do we have on that? You ready to look at a cosine graph?
Sure.
Sure. Okay. It is not as bad as it looks. Now, notice if I go back to my beginning one, notice that I have the b value factored out here, okay? And that's gonna make it much easier to find your c value, which means that if we're given something that's not in that form, our first step is going to be to factor that b value out. So, what is the b value, or what's being multiplied to our x? 2 pi. So we're going to factor out. Now it's still on the inside. We're just factoring it out from the x and from our c value. So if I have 4 pi and I factor out a 2 pi, what do we have left?
2.
Just 2. So I have a plus 2. Are we all okay with that? So that makes it look a little bit nicer. So what is our amplitude this time?
3.
It is 3. What do we also have going on the outside there?
-3.
Yeah, it's negative. Okay, so what's that negative going to do? Yeah, it's going to flip it. So we're going to think about that here in a minute. But right now our amplitude is 3. Do we have a b value this time?
Yeah.
Yeah. What's our b value?
2 pi.
2 pi. So if I have 2 pi divided by 2 pi, what's that give us? Just 1. Okay, do we have a phase shift? Or something being added or subtracted on the inside?
Yeah.
Yeah, what is it?
4 pi.
On our new one.
Plus 2.
So
Okay, so 2, so that's going to go 2 to the left, because remember it's the opposite of the sign. Then do I have a vertical shift? Do I have anything being added or subtracted on the outside? No. Now, what does cosine normally start at? 0, 1, right? Because it starts at the maximum. Then it has its 0, then its minimum, then its other 0, and then it's going to end at a maximum. But what did we say is happening on the front there? It's being flipped. So basically that's just going to take anywhere that we have a maximum, it's now going to be a minimum. Anywhere we have a minimum, it's now going to be a maximum. So we said that we shifted 2 to the left, yes? Does that have a pi in it? Does 2 have a pi in it for my phase shift? No. So does it make sense for my units this time to have a pi in them? No. Like before I shifted pi over 3, so it made sense for my unit to have a pi over 3. This time I'm shifting 2. But I don't want to have pi's this time. But I am going to go by 1/2. Okay, just so that I have a little bit of space. So my first point is at -2. And we said that we're going to start at a minimum. Where's that minimum going to be?
-1.
Not -1, because what's our amplitude? 3. So it's going to be at -3. Okay, and if we're starting at -2 and our period is 1, where is it going to end at? What is 1 away from -2? -1. Or -3, but we're going to go to the right instead. But yes. So I'm also going to end at a minimum. Which part? So I'm just trying to find the ending spot. So like if I'm starting at -2, okay, I know that I also have to end at a minimum. So I'm just trying to find where that is. So I'm going to take the period, so that was 1, so I'm just taking -2, adding the period, which we said was 1, which means that it's going to end at -1. Okay, and then just like with our sine, for our cosine, it's also very, very symmetric. So halfway in between is going to be our maximum, which is at 3 this time. Halfway in between each of those are the zeros. So that would be 1 full cycle. Okay. Sometimes it might ask you to draw like 2 periods of the graph instead. It's just gonna keep repeating itself. So you can draw as many or as few as you need. Yes? No, maybe. What questions do you have there? Question? Yeah. Alright, let's look at one last one. It's not tangent. Tangent is a whole other beast. We're gonna do that one next week. But for today, it's a cosine. Focus in up front, please. Okay, so we have a cosine. What's different about this one? There's no parentheses, so do I have a C value this time? Or is something being added or subtracted on the inside? No, but is something being added or subtracted on the outside? Yeah. Now it's on the front, but does it matter if I add something on the front or add it on the back? Is that the same thing? Yes. So even though the 2 is on the front, it's still acting as our D value. Are we all okay with that? The reason why sometimes they'll put it on the front is because sometimes if the like +2 is on this side, people will get confused if it's on the inside or the outside. Now, if there's not parentheses, then it's on the outside, but it's still just clearer if it's on the front side. So that's why they put it there. Okay, so again, we're gonna go through our ABCD. What is our amplitude here? 3. Okay. What's our B value this time? Or what's being multiplied to the x? 2. So 2 pi divided by 2 gives us 5. Okay. Do we have a C value? No. So that means that it has not been shifted left or right. Do we have a vertical shift this time? Yes. What direction? So remember, vertical shifts are up or down. So it's going to be 2 up, because it's a +2. Because your D value, if it's on the outside, it's the actual direction, versus the one on the inside is the one that's the opposite direction. Now, the easiest way to take care of your vertical shifts is basically we're going to say, okay, I'm shifting everything up 2. So I'm going to draw myself an imaginary line there, because that's going to act as my new x-axis. So I'm going to pretend that that's the x-axis now. Because now, let's also remind ourselves, where does cosine normally start? 0, 1, so it starts at a maximum. Then we have our 0, min, 0, max. What's our maximum going to be at this time? So what's our amplitude? 3, okay? So normally it would just be at 3, okay? But it's going to be 3 above our new x-axis. So I'm going to go up 3, which basically puts it at 5. Now, what's our period this time? Just pi. So if we go by pi's over 2 again, our ending point is also a maximum, would be at pi. Okay, halfway in between is going to be our minimum, which is 3 down. So remember, it's 3 down from our line at 2. So what are we actually at?
-1.
And then our zeros are technically where we're hitting that line instead of actually on our x-axis. And then we can just connect those. And if we wanted to, we could keep going and so forth. Okay. But one period would be from here to here.
Yeah, how did you find the minimum?
So just like normally, if my amplitude is 3, right? My max is at 3, my min is at -3. Okay? But this time it's gonna be at like -3 from that like line at 2. So I'm going 3 down from 2, which is what got me to -1.
Okay.
Does that make sense?
Yeah.
Other questions?
Mm.